Hi class, in this video we're going to walk through doing a repeated measures or within subjects ANOVA in SPSS. So our data is already set up where I have the participant ID in this left hand column, and then I have the scores for each person on the three conditions or three times. In this case we have three different types of Oreos that they're eating, and so this individual ate an original Oreo, scored it, they gave it a score of 18. Ate a double stuffed Oreo, scored it, and they gave it a score of 25. And then they ate a golden Oreo, scored it, gave it a score of 0. And we did that across the 34 people. So person 2 did it, person 3 ate 3. So all 34 individuals ate 3 Oreos each. So we have 102 total tastings or total ratings across these 34 individuals. I have given each of my variables labels, so ID, I could change this to part ID, so it's the participant ID, and then original, double, golden. I could change these to original Oreo. That maybe would help my data be a little more intuitive later. And then for each of these, their ratings can't have decimal points, so I've removed the decimal points. I've just set these to be 0. On values, there's really no reason to use values in this case. Participant ID is nominal, and then the scale of measurement is scale on all the rest of these. So I can go back in, go to Analyze, and under General Linear Model, I can select Repeated Measures. I have a factor. If I hadn't set this up, I'll remove it so you can see. We have type or type of Oreo, and there are 3 levels, meaning the person ate 3 Oreos, so we have 3 conditions, and each person is in each condition because it's a within subjects design. So I'm going to click Define, and I can move these. You can either drag, so I can pull these over, or I can click on them and then use the arrow to move them over. So these are my 3 types of Oreos: original, double, golden. Under model, I don't need to do anything. Under contrast, I can select if I wanted to compare, for instance, one to the other. There are different types of comparisons. We're not going to go into those in an introductory class, so I'm going to click cancel. I'm not going to do anything under there. Plots, if I wanted visualizations, that's where those would be. There's nothing to do for post hoc. So I can do what's called a mixed ANOVA, where I have a within subjects factor, like each person ate 3 Oreos, but I also have a between subjects factor. Maybe I think that men versus women, there's some difference there. If I did have that, then I could potentially do a post hoc test for the between subjects factor if the between subjects factor had more than 2 conditions. In our case, we don't have a between subjects factor, so there's nothing to do there. I'm not going to save any scores. Under options, I am going to ask for descriptives. This will give me mean, standard deviations by group. And I'm going to also ask for an estimate of effect size so that I can know if I have a small, medium, large effect. And then I click OK. So you can see my descriptives here. I see that the average rating for original Oreos is 17.32. Standard deviation is 4.989. There were 34 ratings for that. Double is 19.85. So these are just my mean standard deviations for each tasting. And then here I can see the multivariate test. For the moment, we're not going to focus on that because really what we're interested in is the within subjects effects. Meaning that when I look across these ratings, is there a difference within subjects on how they rated original, double, and golden? And I find that that is significant, where my p-value, my significance, is less than 0.005. With the f-test, as we mentioned before, it's always one tell because of the nature of the test. So we know there is a difference somewhere between these 3 types of Oreos. We don't specifically know which one is best and which one is worse. We don't know where the difference exists. Maybe golden is because the score is lower, right? 15.12, different from double, but whether original is different from double and whether original is different from golden, we would need post hoc really to follow up and find out about that so that we could look at that. There is an assumption of sphericity. So the assumption of sphericity is really about the difference scores, and basically, are the difference scores relatively distributed similarly? So is the variability within the difference scores relatively equal? So it's kind of like homogeneity of variance, but with different scores. And from this, we find that we reject the null. That would tell us that we have a significant difference in the variability with the different scores. Again, that's not based on the original scores. It's not based on original versus double versus golden. It's based on the different scores. So if I take the score on original, subtract double, take the score on original, subtract golden, take double and subtract golden, those differences that I get, like when we did the dependent samples t-test, it's about that. And so when I compare those, it does seem that we violate that assumption of sphericity. Because of that, I should probably use one of these alternatives, because the first test, sphericity is assumed. And so we violated that assumption. We really shouldn't use those. In an undergraduate course, we're not going to go into that in depth. So that gives you a basic introduction. Of course, this type of statistic, we don't talk about it too much at the undergraduate level, so do know that there's a lot more going on here. But that's what I would like for you to know for the purposes of this class.